So I'm not going to tell you all about the project, about a part of it. I've put it on here, and I just want to read through this with you and explain where necessary. So we're going to implement a game. It's called Lines of Action. It's for people who are bored with regular checkers. It's kind of like alternative checkers. Do you know checkers? No. You probably call it drafts. Do you understand what I am saying? Okay, so checkers or drafts is the same game. This is a very important game in computer science because it's the very first game where a computer beat a human. So at some point in the 60s, 50s, 60s, there was this computer researcher who made an algorithm to play drafts. And he entered his computer into competitions against humans, and eventually the computer won. Oh, let me unfreeze this. The computer won, and he was banned from competing again. Okay. Oh, just give me a little. Wrong button. Okay, right. So I'm going to start from top to top. No, I'm not. Right. So checkers is an important game. This guy was banned. It happened a couple of times after that. So there was this other kind of weird game that I don't really understand, where you have to design a spaceship. I don't know how to work. Say again? No, it's not. This one was in the early 80s. I think the game is called Euristo. And I don't know how the game works, but you have to design a spaceship. And once again, some MIT guy used artificial intelligence to make a computer player that beat all human players at Euristo, and he was banned. He couldn't compete anymore. I mean, this is not sad. It's kind of like a triumph. But, well. And you know about Deep Blue. We may get there, but the whole point of this exercise is not to write an intelligent player. You just want one that works. So, it's checkers-like. It's played on a checkers board or a chess board. And the rules are very simple. There are only 10 rules. And I want to go through them one by one. So, there are two players, black and white, just as in chess or checkers. The pieces are placed on opposite sides. So on the sides of the board, white is on two of the sides, black is on the other two. I can show you a picture, but I'll also show you my program doing this very primitively. Okay, right. So here we have a board, and all the black pieces are down here and up there, and all the white pieces are on the sides. It always starts out like this. Only the corner squares are empty. Right. Second rule is the players take turns to move. So first black, then white, then black, then white. And we always start with black. So that's the easy rule. Now, almost the trickiest rule. If you want to move your piece, you're only allowed to move it a fixed number of places. I know this is also true in chess. Whenever I play chess and I go, boing, 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 crown me, they complain. Because you're only allowed to make one move in chess. Move one square, unless you're the knight or... Oh, the bishop can move far and the queen can move far. So, but in this game, like a pawn, you're only allowed to move a fixed number of places, like a knight. And those number of places is determined by the number of pieces on the direction, the line you want to move. Now this is tricky, but let's have a look at an example. Let's say I want to move this piece B here. I can't move horizontally because I'm blocked. Not strictly 2, we'll get to that. I can move vertically because vertically it's open, but this little b can only move 2 positions. So 1, 2. Can only move to that square because there are 2 pieces in this column. There are 2 pieces in this line. If there were 3 pieces, you could move 3 positions. If there were 4 pieces, you could move 4 positions, and so on. There are 2 more moves for this B. He can move diagonally upwards like that, but once again, 1, 2 positions next to that white, because in this diagonal B, there are 2 pieces. And the same the other way. This B can move, well, there are 2 pieces, so it can move 1, 2. It can move to that square. Right. It says here, a player may jump over his own pieces, but he may not land on them. Now that's a little ambiguous. What it really means is that if I'm moving and I see one of my own pieces, I treat that as an empty square. So I shall give you an example. Let's move the B somewhere. Let's move this B to that position. So this is from row A, D, to row C, column F. My mistake, I try again. AD, row column, to CF. Is that not what I typed? Okay. I'm making some other mistake. I apologize. Well, it's right. Well, I know what you do. Let's move AB to CB. Okay, right. So here we go. This B has moved from down here to up there. And now, that B, the top B, can move. Let me do it on the screen so it's on the recording. This B, sorry, that's not a B. This B, this black piece here. If it wanted to move 2 places, it could move down to this place. Because there are 2 B's in this row, on this column rather, and this B will move 1, 2 positions. So it treats that top B as an empty space. This is what the rule means. It says a player may jump over his own pieces. Okay. Then, a player may not jump over the opponent's pieces. I just want to clear this. Okay. So this W, this is kind of bad example, but this W can't move horizontally at all because the B next to it is blocking it. The W can't move horizontally at all because the B next to it is blocking it. It's not allowed to move across the opponent's pieces. Even if it weren't, it's only allowed to move 3 positions because there are 3 pieces in this row. So this W would have to move 1, 2, 3 onto its own piece. And a part of this rule says a player may jump over its own pieces but not land on them. So the final square cannot be W in this case, but you can jump onto your opponent's pieces. So let's find an example of that. 3, tricky. Okay. won't work. Okay. Let's make a slightly bigger board. AC to CC. Okay, right. So now, firstly, this W can't move horizontally because there are 3 pieces in the row, and it would have to move 1, 2, 3, but there's a B in the way. It's not going to land on the B. On the other hand, this W can move horizontally. There's 3 pieces in this row. It must move 3 positions, 1, 2, and 3, and it will land on the black piece, and it'll capture that piece. So when you land on an opponent's piece, you capture it, and it's taken away. I know this isn't rocket science, but it can be a little bit confusing. So is everybody clear on the movement? You only move a fixed number of places based on the number of pieces in the line or column, row, column, or diagonal you want to move. And you can jump over your own pieces but not land on them. You can't jump over opponent's pieces, but you can land on them and capture them. Right. Next, the most complicated rule. The goal of a player is to move all your pieces so they are connected to each other. So no piece must be freestanding, disconnected from the rest. And it's going to take a really long time to find to set that up in my game. So I'm going to show you a picture. Lines of action. By the way, you're free to roam the internet for source code. I found a lot of source code, but I'm confident you steal it and you understand it, you can use it. Okay? Because it's really complicated. If you manage to understand that, then you're fine. And I don't think you will want to quite spend that time. Okay, right. So, pictures are loading. I'll show you one in a second. One more thing about the internet. Honestly, I do not mind. You can look at it as much as you want for the project, and look at ideas and look at inspiration. But there's one thing you're not allowed to do on the internet or even off the internet, and that is ask for a human to help you. You understand? What's this? Oh, what's it, Boston? Horrible. Okay. So you're not allowed to ask another human to help you. You're not allowed to send email or pay someone on the internet or anything like that. You are allowed to ask non-humans to help you. Animals, cats, for example. If you can find some kind of machine intelligence to communicate with, you can help, go there and help. Or of course, as always, spiritual guidance from deities, angels, demons, whatever your preference. I think my iNet key needs to be open, so I'll just see if there's any way that my computer is prepared to help me. Yes. Oh, excellent. Okay. And it may not be fast, but hopefully it'll be coming. Right. So, don't ask on the internet for help. With one small exception. Well, it's barely human. You are allowed to post messages on the forum, and a Debbie will answer. And don't be afraid or ashamed to use that. That's the whole point of the forum. So ask on the forum, don't ask on the internet, the wild internet. Right. So I want us to look at this little picture to appreciate how complex the final rule is. So, white had a move, and it moved its marker in that direction. It could move one square because there's only one piece in this whole diagonal. There was no black markers or pieces blocking it, and it wouldn't land. Maybe it landed on a black. No, it didn't land on a black because it only moved one square, and if there were a black, it would have had to move two squares. So it moved one square to an empty space, and now all the whites are connected. This one's connected to that, to that, to that, and to that. The blacks, however, are not. There's this gap. Obviously, there are three islands of blacks. These ones are not. They don't count as connected in any way. Checking connectedness is really, really complicated, and we'll give you some code for it. But we won't cover the code itself until the very end of the course. So that's a bad thing about this game, but apart from that, it is apparently quite fun. There have been world championships, but this means nothing. It just means a couple of guys bought some beer and played in someone's garage, okay? So don't pay too much attention. But I did find it interesting that there was a South African. A South African in your face! I don't mean to upset you. I'm just kidding. I'm sure it's a very boring game. Say again? So, apparently, what's that? Norwegians? Or is that Iceland?
England.
Yes, England, sorry. For someone who lived in Scandinavia for, I don't know, a decade, I think I'd know the flags. Never mind. Okay, fine. England if you want. This is Estonia. At least I know that. Estonia, oh, he's busy. And Dutch and German. I didn't know these games were still ongoing. At some point, there were also computer championships with lines of action, but it's somehow dried up. Maybe the computer players got too good. I don't know, it was called scrambled eggs. You learn all kinds of stuff on the internet. I learned that the hard way. Right, so let's get back to this. You can capture other pieces by landing on them. If you capture all of the pieces of the opponent's side, sorry, of the opponent, that won't be possible. You cannot capture all of the pieces of the opponent because at some point you would have caught the second last piece, and then there's only one piece remaining. And one piece is connected to itself. So at that point the opponent won. If you're still playing after you captured the one piece, there's a mistake. Okay? Not allowed to do that. So one piece is connected. It is possible that I make a move which captures one of your pieces. And now you only have one piece left. And obviously that is connected, so you should be winning. But in making my move, I moved my last two pieces next to each other. So they're also connected. So I should be winning. So it's possible that a move can result in a draw. A single move can result in a draw for both players. It's possible that a player cannot move. A player may be stuck in the middle of four other pieces that surround him or her. So it's possible that players cannot move. In that case, they just pass. Turn passes back to the other player. In theory, it is possible that neither player can move. In a weird theoretical situation, but I don't think you're able to reach that position. And lastly, if a position of the same player to move occurs for the third time, we're kind of stuck in a loop. Who plays chess? Only 5. Who has heard of chess? Who has ever played chess? So I don't know how much you know, but towards the end of the game, both players usually get very, very sleepy. And it's possible that they just repeat the same moves over and over, stuck there in the infinite loop. And then there are rules to say that if you reach the same position 50 times in a row, the game is over. Is that true? Chess players? Any serious chess players? Yeah. Right. So, I know this is tedious, but it's important that you understand the rules, and I'm a little afraid that if I just leave you to it, then you will ignore them. Now, here are the requirements. It's not the rules, these are the requirements. They tell exactly what your program is supposed to do in explicit detail, but I just remembered that there may be some detail left off. So, your programs, you can write whatever you want in Java using whatever library you want. You can try to steal the code as long as you don't steal it from someone in this class. As long as you don't pay someone to write it for you. So no human agent other than yourself should have written the code or stolen the code. Okay? Very easy to obey those rules. You can write whatever you want as long as you satisfy each of these requirements. And if you sneakily satisfy a requirement and we didn't really want you to, then that's very bad, but it's bad on us. So as long as you stick to these, as long as your program satisfies these requirements, you'll be fine. I don't want to read all of them, but I just want to give you a flavor of what they're like and how carefully you should read them. It says here, your program, you must write one program. So a single program. We don't want 5 or 6 different programs that they have to start in different ways to run your project. I think it's going to be that one program. In the past, people have said, yeah, if you wanted to play it like this, then you have to start it like that. If you want to play it like this, then you have to start entirely different programs. We don't want that. So one program, and we'll just assume for convenience that this program is called LOA in the rest of this document. Your program must operate in 3 modes. So test mode, single player mode, and multiplayer mode. And just for today, I'm only going to talk about test mode because the others are similar. It must be possible to run your program from the command line. Very soon we are going to learn Eclipse, which is a very nice environment and makes things a lot easier and more convenient. But when you submit your programs on Sunlearn, we don't have time to load them up into Eclipse and start Eclipse and run it in Eclipse and all that. So we want your programs to run from the command line. The command line that you're learning now is really important. If you're using some kind of IDE and not the command line, you'll have to figure out how to satisfy this requirement. So I really ideally want to say Java, LOA, and then a lot of options. Your program must accept at least 2 command line arguments. So at least those first 2 must be accepted. If there are fewer than 2 arguments, your program must display the following and terminate immediately. So too few arguments, your program must print out this message. Error, too few arguments. If it prints out a little ASCII picture of a cat and says, oops, it almost seems as if you supply too few arguments. You have not satisfied this requirement. It's very cute, but it's very wrong. This is what your program must do if the 2-argument rule is violated. The first command line argument must specify the size of the board. And this can be an integer from 4 to 16. So if it's smaller than 4 or larger than 16, you must print out that it's an illegal size. I know some of you are more advanced and have almost moved beyond the plane on which we usually function And we move beyond capital letters and small letters. So that sometimes you use capitals, sometimes you use small letters, depends on the mood. But for this program, you must obey those rules. So if it says capital error and small illegal size, you'll be penalized if you don't do it exactly like this. Please watch out. The reason for this is not that we are picky or capitalist or small letterless, but it's just that we actually use a different program to mark your program, and that program is too stupid to know the difference between big error and small error. And if it sees anything other than big error, illegal size, in this case, it'll mark it as wrong. So we automate part of the marking process. And that's why you must obey these rules religiously. The second command line argument is the mode, and it must be 0, 1, or 2. Test mode, single player, multiplayer. If the second command, okay, 0, okay, right, fine. So test mode. In test mode, your program must repeatedly display the current board position, read a move, and make the move. So, like my little example program here, that I'm running on a board of size 4 and in test mode, it must display the board, it must read a move, and it must make the move. And now we're back in the loop. It displayed the board, it's waiting for me to type a new move, and it'll display the move again. Make the move and display the board again. Okay, these moves must all just be 4 letters, 4 capital letters. The row and the column, the row and the column. So in this case, I moved from row AC, so row A, column C, this B, to row CC, row C, column C, to that position. So I'm right there. This is the only way to describe the moves. I know it's a little inconvenient because on chessboard you usually have numbers somewhere. E1, 2. So numbers on the sides, the rows are numbered, columns are lettered. But there's a reason for this. And that is that it becomes easier when you're dealing with a really big board to not have numbers bigger than 10 down here. And the moves become more difficult to write as well. So we're going to stick with this ABC for rows and columns, both. Okay, fine. X is the row, Y is the column, yes. Your program must allow one more additional command, quit, which displays a message, this message, and terminates the program immediately. So if the player types quit, which looks like a move from QU to IP, it's not. It means the program must quit. And you can tell that quit cannot be a move because T is already 20 and you know the biggest size of a board is 16. So don't worry, this won't ever be a move. But if the user does type quit, the program must quit. What else? Your program must complain and terminate immediately if the move is not quit and it's not a valid move. So if it's illegal letters, or too long, or too short, or you can't move from AA to BB because there's no piece of AA, or what have you, your program must display invalid move and quit. And then, after a while, if the game is a draw, then your program must display the winner, like so, and quit immediately. You can tell that it's test mode because it's quitting immediately all the time. A little second. It's a trivial little game, but too hard to remember. Okay, so A, C, C, C. Moving from this position to that. C, A, C. C, A. So the white is moving what? C, A, C. Did that white capture itself? C, I see. Oh no, it moved diagonally down. Whoa! Oh, I thought my program was broken. Okay, no, so that Y can see I moved down there. It's diagonal. There's only one in that row, so this program is broken. 0 marks. Zero marks. Error, yes. Never mind that. A, B, C, B. Okay. So moving this black up formed the cluster. Okay? So that's okay. And now, let's see, when it is black, your program, this grid your program must display. So I'm telling you this stuff really meticulously because every single year we have a little problem like this. We really cannot mark all the programs thoroughly by hand. So we always try to automate some of the marking so that a program will check and will find that my program is broken because it violates a rule. But every year people make mistakes in the way that their output and input moves. So that it's not always a game, but the way they produce output and input. And therefore, when they do that, they lose marks. And it's sad because perhaps the program worked perfectly, except they wanted to put grid lines around the board. Or they wanted to use a star instead of a W, what have you. So you must stick to these rules extremely thoroughly. Just thoroughly. Row names must be displayed on the left-hand side. Column names must be displayed at the top. Board can only be a dot, a B, or a W. And there must be spaces between all the displayed characters. So you must do this. Otherwise, you lose the marks. Our program won't pick up. And lastly, the program must not display anything else. It must not display a little prompt mark when it's reading a move. It must not display anything else when it's outputting the board. It must not display any other kind of message. Okay. Now, single player modes requirements will be coming soon, but they're essentially identical to the test mode requirements. So all of it is exactly the same, except that you have a little more liberty in when the player makes a mistake, so inputs an invalid move, you can prompt them again. You don't have to quit the whole game. But the most important difference between single player and test mode is that you must implement a player for either black or white. So you must implement a computer player that I as a user can play against. Say again? What? Yes, it's not actually as cool as you think. So there are no limits on how stupid this computer player can be. So it can just try any old move until it finds one that's valid. And it can play that. So it doesn't have to be an intelligent move. Also, if you want, you can build in intelligence. So we'll add bonus marks for people who are truly intelligent computer players. And then lastly, more requirements are missing for multiplayer mode. But we'll give you a piece of library where you can connect with someone else in class and play across the network. So the two players can play against each other. So that's not too strenuous. I'll try to put up these requirements before when? Well, it's what I really wanted to discuss when we introduce the project is how are we going to go about implementing this. But the truth is that until we've got arrays next week, I can't really tell you anything. The only thing I can really tell you is that when you have a move, it's 4 characters, and you can use the string functions we discussed on Monday to look at each of the characters. But apart from that, not much to say. Yes?
Can we use hash maps?
I don't know, Ineke, would you implement this with hash maps?
No.
Ineke says no.
But if you're using an array, you have to set the amount of the recipe. I guess your node will always be a maximum of 16. I guess you could, but
If you do that, I'll punish you. We're not even in this course. Just one day you'll be walking across the street and I'll just swipe you with my card. A gentle tap to Dancing Hospital, but not in coma. That kind of punishment, okay? We'll do arrows next week, and you'll understand what that guy just asked and why it's all wrong what he said. It's false. Okay? Forget the word hash map. Not drugs. Get around. Okay? Now, this is all due by the start of the next term. So you can't write any code really, but just try to meditate on this. By the end of next week, we can start writing the code, and the test will have at least one exercise that helps you write some of this code, if not all of it, but not all of it. In the second term, we are going to look at other libraries for graphics, and by the end of the course, you need to add a graphical interface to this code, so that it looks a little more like this, not with the blue arrows, but a little more like that, and a little less texty. Okay. Of course, if you can already program, you can try this, but I beg of you, stick to the rules. Some years, people show up with their own laptop, like cooled with liquid nitrogen, immense speakers that have roadies rolling into the classroom, and they show this amazing multimedia, three-dimensional version of the project, where it's so realistic, you can't puking after you play it, it's all 3D, it's roller coaster. Doing this, but on a roller coaster, for example, it's a typical kind of thing that at least one of you will do, I know. But unfortunately, we have to tell them, well, that's 0 marks, because you didn't print error illegal movie. And I try to make that illegal. Okay? So stick to the rules. That's how we mark this, so that demos don't go insane having to mark all of these by hand. I promise you, if you break a rule, and we have to go fix your program by hand, or scrape out some marks for you, we're going to kind of hurt you. Probably give you 0. For all your other subjects as well. Do you have questions? Who's done? Anybody started writing the project? Excellent. So we all have something to keep you busy. There's also the stat, which is about loops. And next Tuesday, I will still put up the solution. But after that, I thought about it. Who would prefer me to put up the solutions for the tuts? Okay. But not Roscoe. What? You know your name means rubbish. Finish. That's not. That's Roscoe. Never mind. Okay, right. Okay, so I'll put up the solutions, but I think I'm going to impose a little requirement, and that is that you can't leave the tut until you've shown a demo that all your solutions work. Or the time has expired. So by 5 o'clock you can leave, or before then, like this guy. Are you first here? Right. You cannot leave until you've actually shown a demo that everything works. Okay. Because what I don't want you to do is to say, I'll do it at home, or I'll do it by myself, and you never do it. Okay, I really have to run. I hope this computer recorded most of my voice, because I can't go to